Okay. Excuse me. Again, I apologize for the fan. In this video, this is directed to other developers out there who would like to get this thing running on their machine. So we're going to take a look at the source code. I do the development in Visual Studio Code, or excuse me, Android Studio. But I like to, kind of look at it in Visual Studio Code. I haven't loaded it actually yet in Visual Studio Code, but it does still run a wee bit faster than Android Studio for a lot of things. So in order to get this to build, I had included two open source projects, Obo, it's like sub-modules, Obo and the really nifty template file browser. So I haven't tried to re-download on a fresh machine anything that's on GitHub, so you might run into problems getting it to build. So hopefully this will help you get it fingered out, as it were, to get it running. So the first thing to note is the submodules I mentioned. This is just the project listing straight from the file system. So this is the File Explorer submodule I mentioned, and I believe the source code is included there. So even if the submodule connection breaks, because this is another Simple File Explorer, is another open source GitHub project. In the CPP though, oh, excuse me, before I move on, Obo, wherever it is in here, is also a submodule. This submodule happens to be here, but the other one, not quite sure where Android Studio has thrown that. But it definitely pops up in Android Studio. So we're going to look at how and why that is through the CMake lists, and you're going to want to also look at lead build Gradle. That one. Alright. For a second I was using Android Studio commands. Okay. Yeah, we want this one. And this CMake list.txt. And again, this is just the file system folder structure. There is in Android Studio a project view, which is essentially what you're seeing in Visual Studio Code, and there's also the I think they just call it the Android view, which condenses a lot of this. Obo shows up there as a submodule or not, but whether it's Obo's as a submodule or not, this is the code essentially you need to get it to work. So if it's a submodule, then this code will work. If it's not a submodule and you have Obo installed somewhere else, you'll have to update this path to get it built. As for the build, I have been using the latest NDK, so you'll probably have to download that. Should automatically try to if you're in Android Studio. But also keep in mind the Simple File Explorer here, but you shouldn't have to change anything. Now my CMake version might be a little higher than what you have. So there's, I'm not sure what Android Studio uses for CMake. I'm using one that I've got. I think this was, yeah. Actually, no, the one on my command line's higher. So this must be the one that Android Studio is using. So it should work, but that might be an issue, because I always try to push for the latest of everything. Not always the best approach, but I pretty much use Microsoft Enterprise solutions and development suites and yada yada yada, and we always push for the maximum. It's not necessarily the best thing to do in Linux. Many of you may know out there. Anyway, that's the bird's eye view. There's just the C++ and the Java where the main code resides. So, but the third open source, oh, here's Obo. Here it is as a module. The other used code is this template FFT, which is also where it's the exact same license for this whole prototype sandbox. But if you look in here, this author here, and I believe he wrote a Dr. Dobbs in the past, but the code that I'm using, if I recall, this code here, yeah, this is my slightly modified one. I don't think I'm using as many stuff in the Infinite series that's basically truncated as he does. But anyway, it gets complicated. So yeah, this FFT by Victor, I believe, or no, excuse me, Tim. Here, not Victor, Volodymyr. Again, if I mispronounce that, I am so sorry. Which then computes the autocorrelation and then ultimately the pitch, I believe. This is the other open source piece. I guess there's quite a bit of open source in here. But this was pulled from basically, let me go and pull up that project. It was actually it's also a GitHub, but I'm not using it as a module, and I highly modified the code. I want to make sure credit is due where it should be. And I think it was pitch something or other. I think we're just going to have to browse all of the different open source things that I've been playing with in the past 3 months or so. Let's see. I'm thinking it was in here. Yes. This fella had compiled a series of well-known pitch tracking algorithms. I didn't get around to doing the probabilistic yen or the probabilistic NPM, which uses something called Markov chains and some other hidden, I guess you could refer to as hidden information searches and whatnot. But anyway, it does do the first one, but it's been modified. So in his original code, I believe he used the fastest Fourier transform of the South. So it has been swiped out to use the aforementioned Fourier transform by Tim and Volodymyr. Excuse me, Volodymyr. I'm so sorry. I'll figure out how to pronounce that. I'll even learn the Cyrillic at some point when I get to it. So yeah, this has been modified. I still need to update comments in this, so I did want that to be known. But it does fairly well. It's essentially computing the same kind of autocorrelation that you find in this file, which is essentially all the digital signal processing algorithms in that list. And feel free to use some of the other stuff that I did play with in here. But the pitch estimator 2 is what is being used, I believe. And you can see that in the native library, or nativelib.cpp. Pretty much is the offshooting point from the C++ code meets the Java code, or what they call the JNI native bridge code. So pitch estimation is using, pitch estimator 2 right here. Okay. I have a lot of different sandboxes, and they're mix and matched branches and things that I do locally. So please keep in mind this coding and style is not at all what I expect in the final project, hence the name SANDBOX. Also note that there's these debug file dumps, and if you change these folders where you have permission and whatnot, you just get it to match up. It will actually dump out debug data. It records a WAV file. When you listen to the WAV file, there are occasional pops, and I am working on that. I don't think it's on my end. I think it has to do with the oboe library and then trying to keep the input buffers as empty as often as possible. Don't know. I'm going to be hitting them up probably tonight or tomorrow on that. And that just monitors the mic input so I can take the actual audio in somewhere else in like MATLAB and analyze it. But it overwrites every time you hit start record again, so wherever you put it. And these text files are actual values that are basically CSV. The NAX is the normalized autocorrelation. DSP out is like the final audio output, what's actually being shown on the screen in the background when it does the pitch detection. That blue stuff is actually that whatever pitch detection stuff comes out of there. Pitch estimates.txt, pitch MIDI. I'm looking here because it tries to detect the closest it can pitch-wise for the human or the instrument, and then it chooses just by straight linear distance, Pythagorean distance, no other logic at all, to whatever MIDI note matches that pitch. Oh, and a correction on that first video. It's not 11,000 kilohertz. It's 11,025 hertz, approximately 11 kilohertz. And I don't know if oboe is doing the downsampling when you look in the recorder. I've got it set up according to their documentation that it is not using this voice recognition stuff, which, anyway, these settings are supposed to not allow oboe to do anything, just like give it to my app straight raw as possible. I am processing in 16 bits, so I'm guessing the device is recording at that sampling rate directly. I don't know that yet. Oboe is lacking in some of that, but it might not necessarily be too important for the ultimate goal. So as is, it is the low latency solution via the oboe library, which makes a switch between audio, which is the newer Google audio library to use in newer devices moving forward, but it also still supports, as do all other devices prior to audio, Kronos' open, I think it's OpenAL or OpenSL sound library, audio library. I think it's sound library, which is a bit more closer to C and not quite as easy to use as oboe. But oboe should switch between the two. Audio is always going to get you the lowest latency when going between the two on newer devices. It's hit or miss on older ones. So hopefully, as time goes on and oboe matures, a lot of those kind of issues will be just sort of dealt with. So I can write, like this code here, that's a recorder, and then passes on its audio somewhere else without locking. This utilizes an atomic lock, and the file dev dumper has actually it dumps like the CSVs I mentioned earlier, debugging information, the actual WAV file data, and so Media Streamer was to work in conjunction with the Simple File Browser or Explorer submodule, and made some traction on that. So that's why you see the oboe player here, which isn't used at all in the app, or the prototype app right now. This is just the code that I wrote up to do what it's doing, but instead of the input coming from the mic, it's coming from a streamed file. So that's still in the works. Because on phones that it just can't do real time, or for example, someone wants to use Bluetooth, and this is something else I need to explore. I don't want to call it like offline recording, but maybe it'd just be nice to have to be able to get it from a file or from a mic sensor, right? So anyway, that's just a quick tour of the code. And like I said, in CMake lists for the oboe location. And it should work as is. If oboe is there and or remains a submodule, this shouldn't need modified. For the build, you'll probably have to download this NDK, watch your CMake build version, find out what Android Studio is using, and just make sure it matches if you use Studio to build, which I highly recommend. Now, if you do have the tools, you can do, in Windows, I don't know what the commands exactly would be. In Mac OS, it should be the same. But you can go ahead and assemble and build without Android Studio, without going into it. But you got to have all your Android SDK and NDK build tools and your path set up and things like that. But that should build, and then you can get your APK and use ADB to deploy it if you wish. Not even touch Android Studio. So that should work. Again, making sure oboe is a submodule and the simple file explorer submodule is there. There's been some changes on GitHub, and just like with tokens, I don't know what else has changed since then. So I just use regular old Git generally since the end of 2018. My own personal repositories and whatnot. So let's look at the same SANDBOX repository, but now I'm going to use this Android view. So now you can clearly see, well, here's a simple file explorer as like another module. And actually it doesn't display oboe like I thought it would out here. I mean, it is technically C++ project, is also a repository submodule. This is written in Java, so maybe only Java stuff is out there. Makes sense, right? Hey, I didn't make this thing. It has come a long way. It's gotten a lot better, I think, than what it was doing circa 2019. Eigen is not used, but it's in there just because there's a good chance I might use it. Maybe not in this particular project. Ultimately, we'll see. But definitely in others. So I keep it around in case I want to even just try something quick with it. And you'll find a lot of code in here like that, where I do little tiny experiments that are a function, and then I think we saw that in here with the DSP, like the different pitch trackers. But anyway, I think that should get you started. It should ask for permission to use the mic. It should ask for file permissions, but if it doesn't, you can go into the settings and go ahead and give the file permissions manually. Let's see. I think that really about does it. So you have filter, eigen, they're not used. Template FT, it's been modified. And then the NPM, which I need to actually update the comments on and such as to where that code came from. But anyway, that should allow you to hopefully get a successful build. And as you can see, it's still building over here. All in all, it's not a lot of code in this thing. There's actually more code in here that it's not even using, that I will get around to getting rid of in another subsequent check-in or commit and push. But yeah, not a lot of code to pull that off. So the sky's the limit. Like I said in the last video, some of the more advanced pitch detection that I think would really be outstanding. And in conjunction with having my own synthesizer, so that I know the output without having to go like chase it to sound cancellation and thus no headphones. This will allow like any kind of vocal inflection can change the timbre in real time kind of possibilities. So the app could, and its capabilities with what I'm going to implement next in terms of pitch tracking, won't just be triggering MIDI. It could be, I guess you could say, like you could control other aspects of the timbre, so like phase modulation, delay, whatever kind of effect in the synth output from that point. But a really good paper to get an idea of the tools that are out there that are relatively new, and starting to get traction is, like I mentioned, this Constant Q, which alone is not going to do it, but Constant Q and the fan chirp is and some of these other aspects. And this paper is very good for getting right to the nitty-gritty in a very concise way. But there's even better ones, like this one here. It has some really good pictures. So like this is a well-known short-time Fourier transform, and this is the Mirex database. So it might be voices, I'm not sure. It's definitely in the class of what they call non-stationary harmonic oscillators. Yeah, or like people's voices and such. Drums and cymbals and things, they're not in the same class as harmonic oscillators. But anyway, it's kind of hard to tell from these pictures, but you get more clear and crisp representations of the data. And in this graph here, like I'm using Fourier transform to compute the autocorrelation. But had I not used the autocorrelation and used a frequency domain based algorithm, I'd be using this Fourier transform, like in these first two graphs here and here. But with the Constant Q and fan chirp by themselves, you can see clearly more defined patterns and peaks and whatnot. And when they're combined, you can really get some very, very sharp representations of what it is that you're really hearing. So this is what they call the F0 gram, F0 being the root harmonic in an instrument, whether the first harmonic is even there or not. So you might have like a phantom first harmonic, all the other harmonics in an instrument, but perceptually the pitch is still the frequency of whatever the root would be if it had any perceivable amplitude, right? So that's what this type of graph shows. And you may now notice in this paper that it's actually looking for polyphony. And this one also had an implementation. So a lot of these transforms, and here's melody detection scores. So the fan chirp transform plus the Constant Q transform together, you're talking about extracting a melody from other music mixed with it, you see. So it's actually far superior just from that alone compared to what the prototype now has, which is, like I said, I could keep working on the algorithm that's in it now and get comparable scores that we're seeing, but we need something heavy duty like this to be able to differentiate like timbres. Vibrato will be much easier to track and ascertain. It's just it's better. And it's well within the capabilities of the hardware to do this in real time. So, again, thank you for your time and your consideration. And please don't hesitate to contact me. Let me know any kind of desire or comments in this app I'm making, and we'll talk and see, weigh and consider, can I work it in and whatnot. And if the campaign is successful, I'm going to take a few days to regroup and just sort of lock myself in a room, kind of near nature, but solely work on this, completely somewhat isolated from anyone I know, and just hammer this out. And probably a lot of programming work at night. That's what I do. But anyway, thanks again, and have a great day.